Hello, Math 005. What we're looking at in this lesson is going to be 3.7, which is point slope form. This is actually going to be your very last section in Unit 2 because we are cutting some out due to what has been going on. So this will be your last unit for Unit 2, or last section for Unit 2, rather. So the first thing we have here is what is point slope form. Now we've talked a lot about a lot of different forms and formulas in this unit. So here's another one you want to make sure you know. The point slope form is going to be y minus y sub 1 equals m times x minus x1. Now where this comes from is from the slope formula. If we were to be solving for the m here, we'd be dividing both sides by this x minus x1. Well, if we divide both sides, then you're ended up with the slope formula because you'd have y minus y1 over x minus x1. So that's where it comes from. Okay, so let's go ahead and see how this is going to be used. So we're just going to dive into some examples here. We want to give an equation in point slope form. Make sure you read carefully to these questions so you know which form you're supposed to be answering in. And then we want to state the slope of the line and a point on a graph. Okay, so they're giving it to us in point slope. We have to figure out the slope of the line and a point on the graph. So the first one, y minus 3 equals negative 2 and x minus 5. Well, we can see that the m, which is our slope, is going to be right in front of the parentheses. That means that this negative 2 here is going to be our slope. So our slope here is m equals negative 2. And then our x1 and y1, these are going to be our points. That's going to be your x-coordinate. This is going to be your y-coordinate. So in this equation, we have the x1 is going to be 5, and the y1 is going to be 3. Now you can see here, you want to be very careful. You'll see that there's a subtraction sign here and here. Since the form has subtraction signs built in, we do not take them into account. So we're just getting x is 5, y is 3. Okay, the next one. We have y plus 1 equals 1/2 times x minus 3. Well, same idea here. Whatever is in front of the parentheses, that's going to be our slope. So we have m equals negative 1/2. Now we want to be careful because we see that this value here is going to be our x1, and there's the subtraction sign, so we use that value. However, on the left-hand side, we have y plus 1. Well, we know the form has a subtraction, so we could rewrite y plus 1 into y minus a negative 1. Therefore, the y-coordinate is going to be a negative 1 here. Okay, pause the video, try out letter C on your own. Okay, now we notice here that our slope, there's only a negative sign there. So that means our slope is m equals negative 1. Now, when we look at our x value, inside this parenthesis, we are going to have x minus a negative 5. So therefore, the x-coordinate is going to be a negative 5. The y-coordinate is going to be a positive 2. Again, we want to make sure that there's a negative in the form because that's what the form has. So you're just going with whatever value follows the negative sign. Whereas here we change it, a negative 5 follows it. Okay, so now we're going to be going the other way with it. Now we're going to be given a point and we have to write the point slope equation. So the first one we have m equals 2/3, so that's our m, and then the 4 is our x1, the 9 is our y1. Again, we want to use the form y minus y1 equals m parenthesis x minus x1. So we have y minus 9 equals 2/3 times x minus 4. Again, since the form has subtraction signs built into it, we just want to make sure these values are what follows the subtraction signs. All right, the next one. We have here our x1 and our y1, and we know we have our m. So now we have y minus a negative 3 equals negative 2 times x minus 2. You could rewrite this to y plus 3 equals negative 2 times x minus 2. And that would be our answer. Okay, the next idea is we want to write now a slope-intercept equation. So think y equals mx plus b for the line with the given slope and containing the given point. So we have to create the slope-intercept. Now we know that this b here in our slope-intercept is the y-intercept. This point is not a y-intercept because it doesn't have 0 comma something. So we cannot just take the 9 and substitute it in. We want to think now, okay, we know a point and slope. So we know a point and slope. If we know a point and slope, we need to use point slope. We know a point and slope, we need to use point slope. And then we'll finish with slope intercept. So with this, we know that the 4 is x1, the 9 is y1. So we have y minus 9 equals 3 times x minus 4. Now that's in point slope, but we want slope intercept, meaning, oops, sorry about that, meaning we want to solve for our y. First thing we have to do is distribute on the right. So we get 3x minus 12, and then we have to add 9 to both sides. So we're left with y equals 3x, and negative 12 plus 9 is a negative 3. And so we get y equals 3x minus 3 would be the slope-intercept equation. Now, how could you check this? Similar to how I explained in the last video. You press the y equals and type y1 equals that. So type y1 equals 3x minus 3. Then press graph. And then press trace. Then press 4. And then enter, and you should get the y value of 9. Another way you can do it is substitute in the x value of 4 here. 3 times 4 is 12. 12 minus 3 is your y value of 9. So now what I want you to do is pause the video and try out letter B, and you're going to follow all the same steps I did in letter A. So go ahead and try this one. Okay, you can see first thing I did is since I know a point and I know the slope, I have to write a point slope. So y minus y1, so this would be y minus a negative 1, I just rewrote it as y plus 1, equals m times x minus x1, which is just x plus 4 then, because we have minus a negative. Distribute my negative 1/2 to get negative 1/2 x minus 2, and then subtract a 1 from both sides to get y equals negative 1/2 x minus 3. Okay, the next thing is now we are given the equation in the point slope form and we have to graph it. Please do not try to just solve for y here and graph it. Does that work? Yes, most of the time, but you could end up with ugly fractions that aren't going to work well for you. So what we can do to make this the easiest for you is just pull the point and the slope right from this. So we know that this 2 here is going to be our m. So our slope is going to be 2 or 2 over 1. Now the point here, we know that this 1 is x1, this 3 is y1. So here we have the point. We know a point on this graph is 1 comma 3. Now we also know that since the form has negatives, you're only using the number that follows the negative. So these would both be positive values. So all we have to do is start by plotting this point 1, 3, so over 1, up 3. And then from here, the slope is 2 over 1, up 2 over 1. And then all we want to do now is draw our line. And we have our line. So you don't have to solve it for y or do any extra math. Okay, next page. On the previous page with right here of knowing the slope and a point. If you know, okay, so the next one, graph y plus 1 equals negative 4/3 x plus 2. This one you'll notice is not going to be very easy if you try to solve it for y. What I want you to do, pause the video, find your point, find your slope, and graph it. Okay, you'll notice from this one, I actually first started by rewriting these as negatives. So instead of y plus 1, I rewrote it as y minus a negative 1 and x minus a negative 2 because we know the form has subtraction signs in there. So therefore my points, my y coordinate is going to be a negative 1, my x coordinate is going to be a negative 2. And I know my slope is this negative 4/3. So I started by plotting the point negative 2, negative 1, and then from there I go down 4 places over 3. And then plot my next point, draw my line, and I'm good. Okay, the next three problems, I'm going to go through example 6a, 7a, and 8a, and then I want you to try the b's for each of them. So in example 6, what we're doing in example 6 is we're writing an equation of a line. When we see equation of a line, we want to think y equals mx plus b. That contains a specified point and is parallel. When you think parallel, you want to think same slope to the indicated line. So we need to write an equation of a line in this same form, but it has to be parallel to that, but it has to go through this point. Well, we know that parallel lines have the same slope. So here the slope is negative 2. So now we know the slope and we also know a point. Well, this is going to go back to what we point in a slope. You need to use point slope. So first thing I'm going to do, and I'm going to write this in red just so we can keep it different, is we want to use point slope. So y minus, remember x1 and y1, y minus a negative 5, which makes that y plus 5, equals negative 2 times x minus 2. And then I want to solve for y. So we have y plus 5 equals negative 2x plus 4, and subtract a 5 from both sides, so we get y equals negative 2x minus 1. So this, let's get this back here, this would be our final answer here. So again, we first had to identify the slope, and then we used the point that we were given. We use point slope first because we know a point in the slope, and then we have to solve for y. Again, we'll come back and let you try letter B. The next kind, in example 7, similar to this, is we're writing an equation of a line. Again, this is going to be in the form of y equals mx plus b, and it has to contain the specified point, but now it has to be perpendicular. So you want to think the slope is an opposite reciprocal and to the indicated line. So now you'll notice again that this is solved for y, so we don't have to do anything else. So we see this slope here is 3 over 1. However, we want to find the opposite reciprocal. This just means perpendicular, this little notation here. Oops, let's go back here. It's like this, okay. That means perpendicular. So now the reciprocal of it would be 1/3, and then the opposite would be a negative. And then we have our point here, which is going to be x1 and y1. So we have y minus y1, so plus 5, equals m, which is negative 1/3, times x minus x1, which is 6. So we have y plus 5 equals negative 1/3 x. 1/3 times a negative 6 would be a positive. 3 goes into 6 2 times. And then we have to subtract 5. And then 2 minus 5 is negative 3. And then again, we could check our answers. Again, same idea as before. Graph this into y1 equals on your calculator. Graph it, hit trace, and then a 6, and then negative 5, and the point should lie on that line. Or you could take these two values here and substitute it in. Negative 1/3 of 6 would be negative 2. Negative 2 minus 3 would give us the negative 5. Again, I will let you try letter B on your own. All right, and the last one we're going to be looking at is write the slope-intercept equation. So again, y equals mx plus b for the line that passes through the given pair of points. So now we are only being given a pair of points. Well, the only thing we know how to do when we have 2 points is to find the slope of them. So x1 and y1, x2, y2. So again, the first thing we're going to do is find, oops, that was super messy. I have to write that a little bit bigger. We have to find the slope first. So we have m equals y2 minus y1 divided by x2 minus x1, which would be 2 over 4. So we have a slope of 1/2. Now, we know the slope and we know points. You can choose either point you want. I'm going to choose 2, 5 because there's no negatives there. So now we have to apply the point slope. If you know a point and you know a slope, you need to use point slope. So y minus 5 equals 1/2 x minus x1. So we have y minus 5 equals 1/2 x minus 1, and then add a 5 to both sides, so we get y equals 1/2 x plus 4. And that would be our slope-intercept. Now you should be able to choose each of these x values of -2 and +2 and substitute them in, and you would get both of those y values. So 1/2 times a -2 would be a -1, -1 plus 4 would give us the 3, and so forth. So now what I want to do is pause the video and work through the example B's for each of these, and you can follow what we did in the part A's as a guide. One of the big differences, at least in the first two, in 6B and 7B, is you need to identify the slope. So in each of these, you need to solve for y first. Same with this one, because you have to identify the slopes of those and then you can proceed on. You can notice when they were given to us, we already had them in slope-intercept form. So go ahead, pause the video, work through them, unpause them when you're done, and check your answers with mine. Okay, go ahead, you can repause it if you want, check your answers. I'm going to do a very quick walkthrough of these. But please, if you have any questions on anything, shoot me an email, let me know where your questions are. You can screenshot it. Let me know and I'll be happy to help. So the first one, you had to solve for y first. We see that the slope is a -1/2. We're looking for a parallel line, so we're using the slope of -1/2 and the point. Use point slope, solve for y. The 3's cancel out here. The next one, again, you have to solve for y first. We find the slope to be 7/2, but we're looking for a perpendicular line, which is the opposite reciprocal. So instead of 7/2, we use a -2/7. And then we use the point, the x1 and y1, and substitute those values in to get y equals -2/7x minus 3. The last one, we are given 2 points. Like we said, you have to find the slope first, which when we do this, we find it to be a +10. And then you can choose either one. I chose the -4 and 2 into point slope, solve for y. You get y equals 10x plus 42. Please reach out if you have any questions. Good luck on your homework, and we'll also have an exam coming up in the near future. Have a good one. Bye.